The cosine law. This is our final part of the trig units that we've been studying. So we've studied similar triangles, which is separate from the rest of the stuff we did. And then we went into SOHCAHTOA, right angle trig. Then we looked at sine law. And lastly, we'll look at cosine law. And there is no tangent law that we will look at, just so you know. So cosine law, what is it for? Well, let's go back in time. So first of all, we learned how to solve right triangles. So right triangles, and then if it was a right triangle, yes, then we went to SOHCAHTOA. However, if it wasn't a right triangle, then we went to, hey, do I have a corresponding angle and a side pair in the triangle? So what we mean by that is, do you have a side and its opposite angle, its corresponding angle? And if you had that, then you went to the sine law. So that's what we learned in the last lesson. This time, if we cannot use SOHCAHTOA or sine law, we will have to use cosine law. I'm going to be honest, cosine law is not my favorite one, simply because it takes more work. It's a little bit more messy on the calculator, and I tend to make a little bit more mistakes when I'm doing it. So, if I can use SOHCAHTOA or sine law, I will use those two first. So let's walk through cosine law. Really, cosine law is an extension of the Pythagorean theorem. For the cosine law, what we will need is two sides and the included angle. So when we talk about two sides and an included angle, we are talking about the angle in between them. And we will use the cosine law when we have three given sides. So if we have a triangle with all three sides given, then we can solve the triangle. So if we have SAS, we can solve for the opposite side, the side opposite the angle. So notice that this is A and this is A. Okay, so we will find, if we have angle A, then we can find side A. If we have angle B, then we will find side B. Okay, and that's the way this one works. It's a messy formula. I want you to take a look at it closely, and then know that I will always provide these formulas for you on a test, but you may be dealing with triangle XYZ instead of ABC. So let's try and rewrite it here for a second. If you have A squared equals B squared plus C squared minus 2BC cos A, what we're doing is A, so A right here, is equal to B and C, so the other two sides, minus 2 times, the other two sides again, and times cos of the angle measure, A. Okay? So if you had triangle X, Y, Z, and we were solving for X, we would write X squared equals, so in triangle X, Y, Z, we'd be talking about Y squared and Z squared, so the other two sides, minus 2 times YZ, and then we would multiply that by cos of, and it would be X. Notice that it is the corresponding side and angle here. Let's look at the angle formula. If you're solving for an angle, so if you have cos A, it's equal to B squared plus C squared minus A squared over 2BC. So notice that in this one we have angle here A, and then we're subtracting A squared. And everything else in that formula is the other two sides. So here it's B, and we're subtracting off B squared. So if we're looking for cos of X, the angle X, we would take the other two sides, Y squared and Z squared, and we would subtract X squared over 2 times, and then we'd do Y and Z. Okay? So these two items right here will always correspond with the bottom YZ. All right, let's learn how to use our calculator. So if you have A squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times cos 56, I strongly encourage you just type this right here in your calculator and let the calculator do that hard crunching of math in there. So if you do that, you'll get the answer 25.16. So that's what A squared is equal to. So we will take the square root of both sides. and we'll get that A equals 5.02 approximately. Over here, again, just how to use your calculator. I'm going to strongly encourage you just to type in this top bit into your calculator. So in calculator, figure out what this value is. So if you type that in, so 4.6 squared plus 3.2 squared minus 4.5 squared, you'll get 11.15 over, and then 2 times 3.2 times 4.6. So again, put this in your calculator. No rounding, just put it in exactly as it is. And you'll get the number 29.44. As we've said before, to get x by itself, it has cos happening to it. So the only way to undo cos is to do the inverse of cos. So we're going to bring it over to the other side. You get cos negative 1, 11.15 over 29.44. And if you plug that into your calculator, you will get approximately 68 degrees. There we go. Let's just take a look at this flow here and find out what you would use for in each of these triangles. So determine if you need to use sine law or cosine law with the following triangles. So if you have a side, an angle, and a side, so this is SAS, by our rules above, we would use cosine law, right? Because that's the two sides and the included angle. Another way to look at this is it a right angle triangle? Well, it's not a right angle triangle, so we're not going to use SOHCAHTOA. Do we have an angle and its opposite side? No, we don't have an angle on its opposite side. We're missing side C there. So it has to be cosine law. For B here we have an angle, side, and an angle. This is ASA. If you remember from sine law, this would say that you have to do, or you would use sine law. Okay? Now, why is that? Again, let's take a look. Do we have a side in its opposite angle? Well, yes, we do. We do because, remember, this angle is 180 minus 65 minus 39, and then we will have our answer. Okay, so we can figure out that answer because they add up to 180. Here we have an angle. Notice that you have its opposite side. So again, we would use sine law. All right, let's try out some examples of using cosine law. It says find side B to the nearest tenth if angle B is 68 degrees, A is 17, and C is 22. So first, let's just make a quick rough sketch. So we have 68 degrees for our angle B. We'll call this A, and we'll call this C. It says that little a is 17 centimeters, so that's this side, and little c is 22 centimeters. So that is this side. In order to solve this problem, we're trying to find b here, and we're going to use the b squared formula, which is right here. So we know that b squared is equal to a squared plus c squared minus 2ac cos big capital B. Let's fill in what we know. So b squared equals a, which is 17 squared, plus 22 squared minus 2 times a 17, b c, 22, and cos capital B, 68 degrees. My instructions earlier were to type this whole thing into your calculator. And if you type that whole thing in, you get 492.79. Next, to get the value of b, this is the goal, we're going to have to square root both sides. So we're going to take the square root of this, square root of that, and we get b equals 22.2 approximately centimeters. And there we go. We just solved for this side length right here. Example 4, find side x to the nearest tenth if angle x equals 40 degrees, A equals 12 meters, and C equals 15 meters. So again, let's make a drawing. So we have x, we have a side A, and we have a side angle C, sorry. So we have 40 degrees right here, we have 15 meters right there, and we have 12 meters over here. And we're trying to find side x, so that's this side right here. So x squared is equal to, let's see if we can remember the formula. So it's the other two sides squared and finding the sum of them. So it's 15 squared plus 12 squared. Then we're going to subtract 2 of 15 times 12 times cos of, and this is the big angle x here. So angle x is 40 degrees. As we did before, type this into your calculator, the whole thing. You should get x squared was equal to 93.2. If you want to know the value of x, we're going to square root both sides. Now we get x is approximately 9.7 meters. And there you go. So this is using cosine law to solve for a side.